I don't know if you've ever played with these sorts of construction pieces before. You can use them to make 3D shapes. One thing I noticed, especially with the icosahedron, is that they're incredibly wobbly because of these hinges until you get quite close to the end. Here it is as a net, and interestingly, it's symmetrical down this center line. But actually, it's not properly symmetrical because this line is a valley fold and this line is a mountain fold. It can flex until these two faces touch, and you have the same limit in the other direction with the mirror image of those faces on the other side. So that's the full range of movement. What if a polyhedron was concave? What if it had indented bits like this? This is a concave polyhedron, for example, though it's rigid. This polyhedron isn't flexible, but it's bistable. And the two stable states that it can be in are quite close to each other. And because this exists in the real world where infinitely rigid faces can't exist, we can actually flip between those two stable states. I've got a bigger one here, and what's interesting is when I squeeze it, I can feel air coming out. The volume of a flexible polyhedron doesn't change as the polyhedron flexes. It's called the bellows conjecture, because a polyhedron cannot be used as bellows. With the icosahedron, with several of the faces removed, I can wobble the structure like this, that's 1 degree of freedom, but I can also independently wobble the structure like this, that's a 2nd degree of freedom. This has 2 degrees of freedom.